Spring integration. So this is going to be the last topic of the day. We are going to learn the concept of enterprise application integration, and then we are going to see what is and why you want to use a Spring integration, and we'll see what makes up Spring integration, and we'll learn the concept of service activator as endpoint, and we'll learn the concept of message gateways, channel adapter as an endpoint, router as an endpoint, and then lastly we are going to see some business use cases. What is EAI, Enterprise Application Integration? So enterprise application integration architecture style could be categorized into two different styles. One is ESB style and the other one is called the pipe and filters style. So ESB style, basically you have enterprise bus in the middle and everyone is communicating through this enterprise bus. So examples of this ESB style solutions are service mix and or mule. Okay. On the other hand, pipe and filter style, one primary example of that is in fact Spring integration. Okay, so there is no service bus in the middle. Okay, so they are all communicating each other directly. So in pipes and filters architectural style, the processing task is divided into a sequence of smaller independent processing steps, and they are called filters. And these filters, examples of these filters could be, for example, decryption, authentication, dedupe, removing a duplication or caching, whatever. Okay, so there might be some incoming order coming into the pipe, and decryption will be done by decryption filter. Then it will be fed into another filter, and so on. Okay, so this is a pipe and filter style. So now let's talk about what is and why Spring integration. Spring integration is motivated by the following goals. So providing a simple model for implementing enterprise integration solutions, and facilitation of async message-driven behavior within Spring-based application, and promotion of intuitive and incremental adoption for existing Spring users. So again, the reason they actually chose this pipe and filter style as opposed to service bus style is that service bus style is pretty huge. I mean, that actually involves a lot of, the huge complex infrastructure. On the other hand, the pipe and filter style is pretty straightforward. Basically you're going to have some kind of a channel which receive input and output. So that's pretty straightforward, and that could be actually used with existing Spring applications without investing a lot of, let's say, infrastructure such as a service bus. Spring integration is guided by the following principles. A component should be loosely coupled for modularity and testability. So whatever the filter should be actually modularized, and they could be individually tested. That could be easily coupled, easily plugged in to create the integrated application. The framework should enforce separation of concerns between business logic and integration logic. So your business logic should not know anything about application integration infrastructure. Okay. So integration should be provided by the Spring integration framework, while your application focuses on business logic. Extension points should be abstract in nature, but within well-defined boundaries to mode views and portability. Okay, so it does provide extension points, and you can certainly customize existing functions, where you can extend existing functions. But it's actually based on pretty well-defined interface. So what makes up Spring integration? So main components is pretty straightforward. There is a message. Message is being transported through the channels. So there is a concept of message channel and then message endpoint. What is a message? Message is very simple. In Spring integration, it's basically a header and payload. Okay, and the headers could contain the commonly required system information such as ID, timestamp, correlation ID, and return address, and things like that. So in that sense, it looks pretty similar to GMS message. Okay. What is message channel? Message channel represent the pipe in pipe and filters architecture. Okay. So producers send messages to a channel and consumers receive messages from a channel. So you can think of channel as like a queue. Okay. So message channel therefore decouples message producers from message consumers and also provides a convenient point for interception and monitoring of messages. Okay. So you can think of it like a messaging queue. Message channel semantics. A message channel may follow either point-to-point or publish and subscribe semantics. This is exactly like JMS, right? So with a point-to-point channel, at most one consumer can receive each message sent to the channel. In publish and subscribe model, on the other hand, there could be multiple subscribers. Each of those subscribers will receive messages. Now, message endpoint. So endpoint primary role is to provide the connection point to the messaging framework for the application code. Okay. So application code should ideally have no awareness of the messaging framework. Okay. So you should not know anything about the message or messaging channels. So again, the whole idea of that your code should focus on business logic, and the messaging should be done by the framework. Okay. So this is something similar to controller in Spring MVC. So the goal is pretty much the same between the two, isolation of application code from the framework. So in the case of Spring MVC, the controller handles HTTP request, and basically HTTP URL will be mapped into controllers, right? And in the case of messaging, so messaging endpoint handle the messages. So messaging channels are mapped to message endpoints. Okay, so you see the similarity. So URL pattern mapped to controllers. Messaging channels are mapped to message endpoints. Okay. Okay, so these are various message endpoint types: transformer, filter, router, splitter, aggregator, service activator, and channel adapter. So we are going to actually look into the service. We're going to actually look into all these endpoints in the remaining of the presentation, as well as we're going to actually do these things in the hands-on lab. So endpoint, when it receives the messages, depending on what it does, is going to be in one of these types. Okay, so first let's take a look at the service activator as an endpoint. So we're going to actually take a look at service activator as one of the endpoint. Service activator basically is a generic endpoint for connecting to a service object to the messaging system. So for example, if you want to have a bean to receive a message, okay, and that bean is actually considered as a service activator endpoint. Okay, so use it when you need to invoke a service method of a service object in your integration project. Okay, so this is the service activator. Okay, all right, and this is your service object. So this is your Java bean. Okay, on the right in the picture, this is the service object which receive input message, and then it will send out the output message. Okay, so when you happen to have this kind of Java bean based service object, the endpoint is going to be service activator. So that is the endpoint. So this endpoint will receive a message from input channel, and then it will send out the message through output channel. Okay, but in terms of communicating with the service object, service activator will be the one to use. So when you in fact configure service activator, you are going to specify this service bean. Okay. All right, so input channel has to be configured, and if the service method of the service object is invoked is capable of returning a value, then output channel also needs to be provided. Okay. So any endpoint will receive a message from input channel and will send out the message through output channel. Okay, so this is the configuration. So suppose I have a service activator called my service activator. Okay, and now if you want to provide your service object, you're going to provide it as a property of that bean in a sense. Okay, so you actually make a reference to it. So we have a my handler, which is a class, which is the bean. Okay, so it's going to receive a message from request channel. So there should be request channel, and there should be output reply channel. Okay, so when message is actually sent through this request channel, basically the service activator will call a method of this my handler bean, and if it returns a response message, it will receive it and it will send out to reply channel. Things might be a little bit too confusing to you guys just listening to this lecture without actually seeing what's happening. So you're gonna actually have a better idea once we do the lab. Okay, so please hold on. Okay, concept of message gateway. So this is a bit confusing concept, in fact. Okay. So the primary purpose of gateway is to hide the plumbing of Spring integration from applications business logic. And the business logic just used a simple Java interface, and the business logic is unaware of the Spring integration API. And this interface, there is no implementation. Basically, Spring provides implementation. Okay, this is actually for sending simple string-based message. So as long as the message is simple string-based message, all you have to do as a developer is using some Java interface. Okay, and underneath Spring will actually create it will create implementation for you underneath to capture that message and send it to to some place. Okay, so we are gonna see this one in an example. Okay, so let's say this is an example of message gateway. So we define a gateway like this, okay, and then we have request timeout, reply timeout, and then we have request channel and reply channel. And then this is actually service interface. So this is just interface. String conversion service, this is just interface, and this is a method. Okay, so in this case, the implementation of this interface will be provided by the Spring framework. You don't have to actually provide any implementation, okay? Because as long as it's actually string-based message, okay? So the only thing, business logic, you as a developer needs to deal with the service Java interface, okay? So basically, assuming the service has convert to uppercase, this is the only thing you have to deal with. So you as a business logic developer, you as an application developer, you don't have to know anything about the messaging framework. Basically, you are going to just use a Java interface. Okay. All right. So that's exercise 1 we're going to do. So hopefully it will give you a better sense on what's happening. Okay. So let's take a look at the example. Okay, so here again we are going to create a simple Spring integration project. So Spring project, and then you are going to select, so you can actually say integration hello world, and here you are going to select Spring integration project simple. Okay, and then again you provide the group ID, artifact ID, and the name of the author, and then package. Okay. And you finish, and then you're gonna run the application. Okay, so you're gonna choose main method, and then in the console you are going to see like it's going to ask you to enter some string, and then the Spring integration is going to actually call a gateway, and the gateway will actually call some. It will actually perform the uppercase. Okay, so let's actually run this one first. Okay, so let me see if I already have. Okay, I don't have it, so I'm gonna create the Spring project. I'm going to say integration hello world. Okay, and then I am going to choose integration, and let's choose something simple. So this guy, standalone simple, and we're going to just create it. And group ID com JPassion examples, and our fiction ID is we're going to just name it as integration hello world, and your name Sang Shin, package again same thing as a group ID JPassion, and examples, and finish. And we are going to run the application. Main, so this must be the one. So okay, so it's running, and it's going to ask me, it's going to prompt me to enter something. So I'm going to say maybe jpassion.com. Okay, and then it will convert into the uppercase, and here I'm going to say my name here, and again it convert to uppercase, and it will just keep doing it. Okay, and if you want to quit it, then you say Q enter, and then it will finish the application. So let's take a look at the code. Okay. So if you see the structure, we have this interface. This is the string conversion service interface. Okay, and then we have a configuration file. So you see there is no implementation of this interface. Okay, so implementation will be provided by the Spring framework. Okay, all right. So now let's take a look at the configuration. So this gateway. So in this gateway, the only thing that you need to provide is basically some interface, and then the method of the interface that you want to call. Okay, and then you have the request channel and reply channel. Okay, and so those request and reply channels are actually provided here. Okay, and then we have a service activator we learned, right? The service activator is basically in this case, it's basically it's just setting up this request and reply channel, and this is expression. So in this case, the expression is it's going to just call the payload to. So the payload is going to be the message, okay, that you typed in. Then it's going to call the to uppercase, and it's going to receive it's going to actually take the message from request channel, and it's going to take the message. It's going to take the message out to reply channel. Okay, all right. So now, if you take a look at this service, this is just interface, and only thing it does have is the convert to uppercase method. Okay, and again, the Spring integration framework will provide some proxy implementation for doing this, because it is like a string-based message. Okay, it knows how to actually create one. And so this is the main method, and on the main method, basically all you have to do is basically reading that configuration file, and then you just get the bean object, and then you're gonna just call it. Okay, So when you call this guy, basically it will send a message to Spring Integration Framework. Okay, so it will actually, it will be received by basically a gateway, and then it will pass it to this service activator endpoint. Okay, all right. This might be a little bit confusing. Okay, so let's actually try the next one. So now we're going to actually modify the code. So instead of actually using the expression, the service activator, in fact, in this case, this is the one that we talked about. You are going to, in fact, call the bean. So you see the reference here. I have a my handler, a bean, and this is the my handler, the bean. Okay. So my handler now actually has, we are going to actually in this case convert to lowercase. Okay. So now, in this case, it's going to now convert to lowercase like this. So my passion and hello passion. Okay. So just a little bit of repeat. Again, let's take a look at the configuration file one more time. Okay, so let's take a look at the one that we just changed, modification of this code. Okay, so we learned the service activator. So service activator endpoint is basically, it is endpoint where you can call some bean. So that's the bean that we're talking about here. Okay, and then service endpoint is going to receive the data through the request channel, in this case input channel, and it will send the data out to output channel. Okay, and because these input channel and output channels are actually the same channels here, this gateway, when the application, so in your main.java file, that's the application. When the application is actually calling that interface, this interface, okay, it will be, taking the message. I mean, it is a framework, integration framework. Will take the message, okay, and then it will send it to this request channel, okay. And eventually that will be sent to the service activator, and then it will call this service bean. It will be changed to lowercase, then it will be sent back to reply channel. So this gateway received that reply channel because it's actually it's reply channel. It's received the message in reply channel, and then that will be sent to the application code. Okay, so hopefully that gives you a sense of how things work. Okay, so I'm going to give you guys about about 10 minutes to try this exercise 1. Now we are going to see how channel adapter is used as the endpoint. So what we have used in the previous exercise is using service adapter as endpoint. Now we are going to use channel adapter as an endpoint in this case. So the message endpoint type could be channel adapter or service adapter and a few other things, right? So channel adapter is an endpoint that connects a message channel to some other systems or transport. So channel adapters may be either inbound or outbound. So this is an inbound, so messages are coming in, okay, this way. Outbound is actually messages actually coming out like this. Okay, so in this case, messages to the external target like this. Okay. All right, so let's take a look at the different types of channel adapters. So there are many different ways of getting the data or sending the data. So these are all possible, like a file FTP, gem file, HTTP, JDBC, Twitter. So there are many channel adapters for this type of channels. So we're going to actually take a look at the file-based, the channel adapter. So here we're going to actually use, this file-based channel adapter. So this is inbound file channel adapter. So this is, inbound channel adapter. ID is files in, and directory is this. So basically, this directory, input directory, is where it's going to, receive the data. and it's going to actually poll. It's going to poll, let's say, the max messages per poll fixed rate. Yeah, so this is going to poll every 5,000 millisecond. Okay, so that's inbound. Outbound channel is basically, this is the directory where things will be written out. Okay, all right. So that is the channel adapter. Now there is another endpoint like a router. So this is a built-in endpoint. So router is actually receiving the message, then it will route to different channels. So this is router. So routers are crucial element in many messaging architectures. So consume messages from a message channel and forward each consumed message to one or more different message channels depending on the set of conditions. Okay, and we're going to see examples of this one later on in exercise 3. And routers out of the box. So the routers can actually route based on payload. So it could be based on payload type. Okay, so if it is a text message, I want to send it this place. If it is the binary message, I want to send it to different channel. Or it could be based on header value. Okay, or it could be based on recipient list. It could be based on XPath, and it could be error message exception type router, generic router. So there are many different types of routers you can create, and these are built-in routers you can use out of the box. Okay, how are you going to actually configure a router? So basically, this is a prefix header value. So this is the header value router. So depending on file extension, in this case, header name is file extension. So if header contains file extension, if extension is CSV, we are going to use CSV files out. So this is the output file channel. CSV, and if extension is XML, then we want to send it out to different directories. So that's where we are using XML files out. For default, we are going to use other files out. Okay, all right. So that's exercise 2. So exercise 2 is basically this is the integration application that polls a particular input directory. And you are going to create some files, and then it will take the files and it will place that file into different output channels. So that's basically what we are exercising this guy. Okay, if the file is CSV extension, it will send it out to CSV files out. If it is XML, it will send to XML files out channel, and all the other case, it will send it to other files out. Okay, so I'm running that application already. So let me just kind of show you. Okay, so so I'm gonna actually go to so this is the input directory. So I'm gonna actually have another terminal window. Okay, so this is the input directory. Okay. So if I create a file, so I'm going to create a file, my CSV. So my CSV, and I'm going to actually save it to test to CSV. So that the application will pull this input directory, then it will actually copy into the CSV. So I'm going to actually search for, let's see, what is the name of the file that I just created. So that is the test2 CSV, right? Okay, so test. So you can see, I'm going to just take this guy out here. So it actually placed that file under this CSV directory, output CSV directory. Okay, so you can see this is the 343 right now. Okay, test2 CSV. Now I'm going to create an XML file. Okay, so this time I'm going to create XML file. Echo whatever, and then test3 XML. So again, that file will be read by the application, then it will be placed. Now it's going to be in in XML. See, now it's actually placed in XML. Okay. So if I create another one, oops, I'm gonna create the full XML, and again, the application will catch it, and then it will place into this XML directory. Okay. Now, if I see, I don't see anything in the input directory because that's actually taken by the application and then placed to the different directory. Now, if it is not CSV or XML, then it will be in other directories. So let me create the echo, and I'm going to 1, 2, 3, and I'm going to say test 100. I'm going to make it, text extension. Okay. So in this case, it will place it in other directory. Okay, so that is the behavior. So now let's take a look at the application. So this is the code. Okay, so let's see the configuration. So we have the inbound file adapter. Okay, so this is actually is in file. If you see in file, this is the file is actually using file adapter. Okay. So this is files in, okay, and this is the input directory, and it's polling that directory every 5 seconds, okay, and then max message per poll is that it's going to get 10 messages, meaning since we got just one file each time, it's gonna just take one, right? So it's not a problem, okay. Now, but if you place like 100, files into that directory at a single time, then it will just take 10 of those first, right? And then it will take the input channel, okay? Then it's actually using routing channel, okay? So routing channel is, basically it just log those things, okay? And then routing channel will be actually fed into this file type router. Okay, so in this file type router, that's the one that we have seen in the slide. Basically, it's actually it's a router based on file extension. So if it is a CS file, it goes to this channel, CSV file out. If it is XML, it goes to this channel. And otherwise it go to other files channel. So if you go to XML files channel, let's go to XML file channel. It basically is outbound, it's a file adapter, and it's actually placing the file into this target output XML directory. Okay, and we also have a logging channel, so we should actually see the messages being displayed. Okay. In the logging. Okay, so that is that. Let me see. Okay, so I'm going to give you guys about 7 minutes to try exercise 2, and then we'll move on to exercise 3. Well, so now we're going to actually see Spring integration in real situations. So far what we have seen is kind of, it's not really intuitive. It does very basic things such as reading a file and moving to some place and things like that. So let's take a look at business use case scenario here. The Cafe sample application that comes with Spring integration package, and this is an example where Spring integration could be used. Okay, I mean, again, this is relatively simple, but it actually kind of exercises the concept. Okay, so each order has a collection of order items, and that is going to be split apart to be processed. So there is the person placing an order in this cafe. Okay, so the orders will be splitted, and if there are many orders, it will be split, and then the drinks will be sent. Yeah, so these orders and drinks, those are the things that are being moved around. Those are data. Okay, and the auto splitter will actually receive auto splitter will receive orders, and then it will send the drinks to drink router. So drink router will send it to hot drink. It will route hot drinks and cold drinks. Okay, so there are baristas which prepare hot drink and cold drink. So these two are in fact Java classes. Okay, and then they will be collected and then send it out to individual order items are processed by the barista, and then drink order items are aggregated in a call to the waiter. So the waiter will actually deliver those things to the customer. Okay. All right. So that is exercise 3. So let's actually run this guy. So it is already provided for you. So all you have to do is basically go to that directory. So you're gonna go to unzipped directory. So I'm gonna just copy this guy. So I have unzipped on the labs directory. So I'm gonna go to labs directory, and I'm going to so this cafe directory. This is where the project is located. So all you have to do is basically run the application. So when you run the application like this, you are going to see basically these orders are being processed. Okay, so basically orders are collected, and this is order 1, and then order 2, ice mocha 3 shots, and the hot latte 2 shots. So each order will have the drink type and the number of shots. Okay, and things like that. So it will actually keep it will just keep serving orders. Okay, and behind the scene is actually going through multiple the channels. Okay, so I'm going to stop right here. Okay, so now let's take a look at the code. So this is actually what's happening. So initially, the message will be received by service interface called the cafe. Okay, and then each order has a collection of order items that will be split apart to be processed. So this is input channel orders. Okay, and this will use a splitter. Okay, so basically it will call the items method of the payload, and it's going to be the splitted version will go to this drinks. So this one goes to the next. Okay, and then router input is going to take the drinks, and then it's going to check whether it is iced or not. Okay, and then it will go to either cold drinks channel or hot drinks channel. Okay, so for cold drinks, basically there could be multiple order items, and each of those will go to either cold drinks and hot drinks. Okay, so this is a cold drinks, and now this is actually using activator, service activator. So it actually calls barista bean, and it's going to call prepare cold drink method of the barista the bean. Okay, and then once that is done, it will go to prepared drinks. Same thing for the hot drinks. Okay, so it's going to call the prepare hot drink method of the barista bean. Okay, and once that is done, both of them will actually end up to prepared channel. So prepared channel is basically aggregator. It's actually the aggregator, and it will aggregate all the orders, the things that are prepared by cold drinks and prepare cold drinks, and then it will go to prepare delivery. It's going to actually call the prepare delivery, and output channel is actually deliveries here. Okay, okay, so it's going to call the prepare delivery method of this waiter bean class, and then the output will be channeled to deliveries channel. So it's actually going to where is it delivered? channel. Yeah, here you go. Yeah, it's ID. And it's basically, the delivery channel is basically standard output channel, meaning it will just, write out things on the screen. Okay, so that's what you're actually seeing. So what you're seeing here is basically the result of the processing of each order. Okay, okay, so now if you take a look at the code, if you actually see the directory structure, okay, we have all this Java code, okay, and then we have cafe demo XML.xml5, which is basically what we have seen here, okay, so this is yeah, so this is actually the main application. It's it's basically the main class, and it just read that the configuration file, and then get the cafe, and here is just calling place order method of the cafe, the object, and as soon as cafe object receive the order, then it will go through that integration, the channels to process it. Okay. This is a cafe. So cafe, this is actually using gateway, and request channel is order. So this is how things get connected. So, request channel in this case orders. And if you actually see orders here, what is the, yeah, so this is the input channel right here. Okay. And the gateway is basically, this cafe is the service interface is basically this interface. Okay, so that's how it's going to receive the input from the application. Okay, and order is basically a collection of order items, and order item is a drink type, shots, number of shots, and iced or not, and order number, and things like that. And here I didn't actually say anything about the barista, but barista also has a class. If you take a look at the barista class, underneath, yeah, so barista, if you see the barista Java, you will see there is actually prepare cold links and prepare hot drinks method. Okay. So this is an example where the things could be more realistic. So where the order comes in, and those things could be actually routed in different places, and they will be aggregated. They could be changed, and all kinds of things could happen through the integration process. Okay. So hopefully that gives you a sense of real life kind of situation example. Okay, so I'm gonna let you actually try this one for 10 minutes, and then we are probably calling a day. Again, I thank you very much for sending me a testimonial, and if you have not done yet so, if you can do it during the next 10 minutes, that would be appreciated.